Hi class, this is Mr. McGuire. We're going to go ahead and start talking about our next topic on the docket, and that is arithmetic sequences. All right, so today during this lesson, we're going to figure out the I can statement for today is going to be I can find the nth term and write an explicit formula. So right now, a lot of those words right there don't make a lot of sense, but hopefully by the end of this little video, it'll make a tiny bit more sense to you. All right, so what is an arithmetic sequence? An arithmetic sequence is a sequence with a constant difference between the terms. The constant difference could be positive, it could be negative, it could also be zero. So as you can see right there on the slide, constant difference is the kicker there. So let's go ahead and look at a couple examples of what that might look like. All right, so first right here, you see I have a sequence of terms. A sequence of terms is just a list of terms. I have a 2, a 7, a 12, a 17, a 22, a 27, and that just looks like it keeps continuing on and on and on. All right, so in order to find that constant difference, I'm just going to look to figure out, can I add or subtract the same exact number between these values to get to the next term in my sequence. So in order to figure out what I have to add or subtract by, I can always take my second term and subtract the term right in front of it. So 7 minus 2 gives me a 5, which means I had to add 5 to get from 2 to 7. All right, 12 minus 7 also is 5. So once again, I have to add 5. 12 to 17, 12 plus 5 is 17. 17 to 22, and you guys get the picture here. So this example is an example of an arithmetic sequence. And I know so because that constant difference, constant means the same. That constant difference in this example is a positive 5. Now your sequences don't always have to go up. Sometimes our sequences can go down. So let's look at this second example here. I'm looking to figure out, am I going down by the exact same number? If you are going down by the exact same number every single time, that is going to be known as an arithmetic sequence because you do have that constant difference. All right, so from 25 to 23, I clearly see I went down 2 units. 23 to 21, I went down 2. 21 to 19, I went down 2. And then 19 to 17, we also went down 2. So you definitely want to check more than just like the first 2, because sometimes sequences can be tricky and maybe the first 2 values go down 2, but then you're suddenly going down by 4. So it's always nice to check as many as possible. In this one, our constant difference, which we'll define a little bit later on today, is D, is a negative 2. All right, so arithmetic sequence is going up or down by adding or subtracting in order to get to the next term at a constant rate. All right, we're going to jump right into an example. We're pretty much just doing one big example in this video, a lot of different components to it, and then we'll wrap up this lesson. So it says Rico owns a sporting goods store, and he has agreed to donate $125. All right, to the Centipede Valley High School baseball team for their equipment fund. In addition, he will donate $18 for every home run the Centipedes hit during the season. And it says the sequence shown below represents the possible dollar amounts that Rico could donate for the season. So I'm going to go ahead and we're going to highlight some important information up here. So first off, he is donating $125 to the baseball team, even if they hit no home runs. So right off the bat, we're starting with a $125 donation. And then he's also going to donate $18 for every home run the Centipedes hit. And then as you can see down here, we do have our sequence right here. All right, so first question, let me go back to my pen here. First question that we have is identify the sequence. Is it an arithmetic sequence? All right, so that's what we're talking about today. Is it something called a geometric sequence, which we'll actually get more into later on down the road, or is it neither arithmetic or geometric? So we know arithmetic has a constant difference. So I'm adding or subtracting by the exact same number every single time I jump from term to term. So here, if you look, if you have a calculator handy, that's great. You can do 143 minus 125, and you see that we added 18 to get there. All right, like I said, you always want to check a couple of the terms. 161 minus 143 is 18. And then once again, from 161 to 179, you added another 18. So since we have a constant difference of 18, we know that it's an arithmetic sequence. So describe how we know, and we can just say because our sequence has a constant difference of positive 18, which makes perfect sense. Every time they hit a home run, he's going to donate an extra $18. All right, determine the constant common difference or common ratio. For this one, we do have a common difference. That common difference is 18. Right, we're adding 18 to our problem every single time. And then now it says, what is 18 in the context of the problem? According to this, it is the money Rico donates per home run hit. I'm just going to abbreviate here, per home run HR hit. All right, so every single time the Centipedes hit a home run, Rico is going to donate an extra $18. All right, so that's all good and dandy. Let's move on to the next slide here. It says, Rico, it's the exact same actual word problem there. It wants us to fill in this table. So if we hit 0 home runs, we still know that Rico is going to donate $125. All right, that's term number 1 in my sequence. This is term number 1 in my sequence. All right, if we hit 1 home run, Rico is going to donate $143. And we know that because that is term number 2 in my sequence, right? This is term number 2 in my sequence. All right, if we hit another home run, Rico is going to donate another $18, bringing that total up to $161. That is my 3rd term in my sequence. And then lastly, if we hit 3 home runs, that's going to be $179. That is the 4th term in my sequence. All right, let me go back up here and write the 1 here. I forgot to write that. All right, so once again, this is just showing my data just in table form. So if you were ever asked, like, what happens if the Centipedes hit 5 home runs? One way to get that answer is through a table. It might not be the most efficient, but as we know, this is an arithmetic sequence because every time you hop, you are hopping by that $18 that Rico is donating. So it's just another way that we could kind of display this arithmetic sequence. All right, next kind of questions here. It wants us to find the next term. So we know we have 1, 2, 3, 4 terms. So technically this question is asking us for the 5th term. Right? So I just want to find out what this number is going to be up here. And since every single time we're jumping, we're adding 18, all I have to do from this last term is to add 18. This is when having a calculator might be handy. Not many of us know how to add 18 super quickly. And we get a total of 197, right? So that next term, that 5th term is 197. All right, so I'm just going to go ahead and write 197 right up here. That is my 5th term. The next question is asking to find the 8th term. So let's go ahead. I want to find the 6th, 7th, and 8th term. So every time I'm going, I'm just adding 18. Right, so my next term, 197 plus 18 gives me 215. And then I'm going to add another 18, and that gives me 233. And then I'm going to add another 18, and that's going to give me 251. All right, so not the most efficient way, but honestly, that took me, a whole 10 seconds. I'm just adding 18 every single time to get to the next term. So that 8th term is 251. All right, let's go through, find the 10th term. I'm going to kind of just write them down here. I'm running out of space. Sorry about that. So I'm taking 251. I'm adding 18 to get 269. And then add one more 18 to find the 10th term. And that gives me 287. So once again, guys, I'm just simply adding 18 every single time to find that next term. All right, so it says the terms above are easy to compute because the common difference can be added, right? Literally every single time, sorry, I just blanked out on how to spell added. Every single time that we go on to the next term, we're just simply adding 18 every time. All right, so what if I asked you to find the 100th term? Like, could I do it using the method that we just did up here in this right corner? Yes, of course. I could add 18, 90 more times in order to find out what the 100th term is. Is it the most efficient way? Definitely not. And like 100 terms, like, yes, obviously you could do it. It might take you like 5 minutes to do it. But what if I said the nth term, right? So nth means any number. So what if I said like the 1000th term? Are you going to want to use this method up here? Probably not. So there's got to be some kind of formula to help us find this out. All right, so this right here is known as the explicit formula. This is probably the most important thing that you guys need to make sure you have down and highlighted and underlined and written down for the next couple of days of our lesson. So it looks pretty crazy right here because there's a lot of variables that we don't know what it means right now. But this formula right here saves us so much time. We can find the 1000th term in this sequence up here in like 10 to 15 seconds just by using this formula. We just need to know how to use it. All right, so first off, we're going to define what these letters mean. I'm going to start at the bottom here. D is our common difference. Is our common difference. So this would have been where that positive 18 went. All right, N is going to be our term number. Term number. So if I was looking for the 100th term, I would plug in a 100 for n, and we'll go through some examples here, so no need to write all that stuff down. A sub 1, the way that you read this is A sub 1. It's a subscript, A sub 1. All right, and that is just the first term in the sequence. First term in the sequence. U-E-N-C-E. And then A sub n, this is going to be what our value is. So this is our value of the nth term. All right, so basically it all depends on what the context of the problem is. So when we're talking about Rico and the amount of money that he's donating, the answer is going to be the sum that he has to donate. So all depends on what the context is. We'll see that here in just a couple of seconds. And this last question right here before we move on, it says, what does the explicit formula mean? The explicit formula is just a quicker way for us to get to some of these nth term examples. Instead of having to write down every single term in the sequence, it kind of is that jumping point where we can jump to specific terms. So super important to know that formula there. A couple more slides, guys. Okay, so it says let's revisit the 100th term in the sequence using the explicit formula. So right here I have 4 terms. Instead of me writing out 96 more terms, I'm going to jump to the 100th term. All right, so the first thing I want to do is I want to define these variables according to my context here. All right, so I know I'm looking for the 100th term, so n is going to be 100. All right, the first term in my sequence is 125. A sub 1 is my first term, so that's going to be a 125 here. All right, D is my common difference. If you don't remember that, that's my common difference. I'm going to abbreviate this, common difference. All right, so we've already decided this. Just real quickly, I'm adding 18 to get to the next number every time, right? It doesn't always have to be addition. It could also be a negative number. You could be subtracting sometimes. All right, so it's a positive 18. All right, so I'm going to plug all this stuff in, and then I'm going to figure out what is my 100th term. So let's come down here. I'm looking for my 100th term. All right, I know my first term. I'm using this formula down here. A sub 1 is 125. My common difference is 18. The term I'm looking for is the 100th term, and this is always going to be a minus 1. All right, we can go through and we can use a calculator for this, or if you guys are super smart with your algebra skills, you can do order of operations. Right, this is going to be parentheses first gives me 99, right? And then I can go through here and do my multiplication. 125 plus, I'm going to need a calculator for this. 18 times 99 gives me 1782. 1782. And then lastly, a sub 100. I just now need to add these two values together. 125 plus 1782 gives me 1907. So 1907. All right, so now what this means in context is if the centipedes hit 100 home runs, actually technically this would be 99 home runs. If the centipedes hit 99 home runs, Rico would have to donate $1,970. $1,970 he would have to donate. All right, guys, like I said, it's just being able to identify where these numbers are. We're going to do two last quick examples, and then we're going to call it a day. So these are just basic, boring problems, no context behind it, just getting us geared towards identifying some of these values. Okay, so first off, a sub 1 is always my first term. So in this example, my first term is a 10. All right, this specific problem, let me get my highlighter real quick, is asking for the 200th term. All right, 200th term. All right, so the 200th term, that's going to be my n value here. All right, I'm lastly going to have to find my common difference. I'm trying to figure out how many spaces are between these guys. Like I said, you can always do the second term minus the first term, which gives me 7. So I have to add 7. And then just double check this. 17 plus 7 is 24. 24 plus 7. So it is arithmetic because they are all adding the same numbers. So my common difference there is a 7. We're going to plug this into my split explicit formula right here. I'm going to drag it down here just so I have it. All right, so we're looking for the 200th term. We have a sub 200 equals my a sub 1, or my first value, was 10, plus my common difference is 7. I'm looking for the 200th term and minus 1. All right, just to save a little bit of time here, guys, I'm going to type this in my calculator exactly as I have it shown right here. So in my calculator, I'm typing in 10 plus 7 parenthesis, 200 minus 1, close the parenthesis, and I get 1403. 1403. So the 200th term in this sequence is 1403. All right, guys, last example, very, very similar. This is actually the first case where we'll potentially see a negative common difference. All right, so for this, I am doing the 66th term of my sequence. All right, let me get my pen back up here. Let's go with red. My 66th terms, that's the n that I'm looking for. My first number is a 52. And now let's find that common difference. Let's figure out what these values are going to be. 52, I'm going to have to subtract 3. 49 to 46, we are subtracting 3. Always, like I said, check a few of these because the first two might match, but then maybe it doesn't start to match. I see that I have a common difference here of a -3, so D is a -3. Come down here, plug this all into my formula. I'm looking for the 66th term. My first term in my sequence was 52. And now this is where it gets a tiny bit tricky. You can do this two ways. Since D is negative, you can do plus a -3. Or some of you guys know that the negative is going to trump the plus here, so you don't really need that plus sign. But you can keep it. It doesn't make a difference. And then we have 66 minus 1. All right, so once again, I'm going to type this right into my calculator exactly as I have it written there. Really convenient if you guys have like a TI-83 or 84 calculator because it has those parentheses. So 52 plus a -3 times 66 minus 1. Now make sure when you're typing in the -3, you're pressing the negative sign and not the subtraction sign. The negative sign, if you're looking at a TI-83 or 84 calculator, is directly under the 3. All right, press enter on that, and I get -143, -143. All right, so if I kept subtracting by 3, and I did this 66 more times, I would get -143. Excuse me, it wasn't 66 more times. If I found the 66th term, because I already know a couple of those terms there. All right, guys, hope this was good for you. make sure you guys start practicing some of this. Make sure you guys take the notes that are attached to this as well and be ready for class activities. See ya.